Hello again. I'd like to thank the viewer for doing some work and trying SciPy. I'm going to address some of his concerns and his results in this video. To add context to everything, I think it's important that we start at the beginning. What is pi? It's based on the axiom that a circle is a single object and that a line is a single line from point A to point B. If we draw a circle with a radius 1, we end up with a circumference that's equal to pi, 3.42. But why is it 3.142? That's not exactly the pi that we calculate or that we approximate. What's the disparagement there? And why is it like that? You would think, in its purest form, if this was in fact pi, that it would show up certainly in a circle with a radius 1. But it doesn't. And we can't explain why. We just chalk it up to approximation. So what I'm suggesting is that we're looking at the problem the wrong way. That's why we're getting an approximate result, but not an exact result. Now, I don't know necessarily what the exact result is. I think that this is the path to finding that out. But what I'm going to point out is that the synergy whole number constant, when set to 1, just like a radius 1, actually produces the 3.42 and change. That's curious. You would think that if this in fact was the true nature of pi, if this decimal was in its exact form the nature of pi, we would find this exact number in multiple places, but we don't. We always find these numbers that are close, that are approximate, but they're close. So it's within a range, and that's really what pi is. And why is that? And again, I think this comes back to the whole single object kind of thinking and something called Zeno's paradox. So the idea that we could take a line from point A to point B and have the distance and then keep having the distance infinitely and never touch is a paradox. And I think it's the wrong way to look at it. Because of course you could take any line and pick some arbitrary number and divide that line by that number. It's the exact same thing. I can just keep increasing the number of lines that I want to use to divide. You're not actually looking at how something grows or how it actually can naturally divide, which I think is key. How something can naturally divide. See, we think that just because something works mathematically or something seems plausible mathematically, that's how it happens in the real world. More often than not, that's not what we observe. That's not what we observe. So we have to start really looking at why or how we calculate things if we really want to understand what's going on or where these small errors are coming from. Because collectively, small errors can add up to a lot. And that could be the difference in an equation working out or not. So I think what's really going on is that this paradox and this way of thinking of a circle being one object and a line being a single line of a set length is that it's artificially constraining pi. So none of the equations that we use pi for can be natural, right? And I would suggest that if we look back here at this pi gradient or the Syp gradient, that unlike our approximation of pi, you will find any value of pi in this Sypy gradient for what you would see in the natural world. And I'm not sure if it's clear what that means or why that is, but essentially it's because when things kiss, how they grow, when things grow beside each other, right? They're never going to occupy the same space, right? They're going to touch, but they're not going to occupy the same space. And by setting a set length or a set unit of a circle, we're confining and constraining everything. And that's, again, something we don't see in the natural world. It's something we don't observe. So we need to take that into account with the way we calculate things. Because we know that space is expanding. And that space is expanding because of this growth. Not because things keep having, but because things keep growing and growing side by side on a molecular level or atomic level. And if you can imagine this line of circles wrapped around a circle and constantly adding more and more circles or more positions, that line that you would see as a line perceptively, the ratios are constantly going to be in flux as each new circle or each new position is added. So now I'm going to address the viewer's concerns and we'll look at what he did to the code. Okay, so here it is. I have it running with 4 up. I'm going to scroll down to where he made his change, and he stated that if we multiply n, which is the position, by 100,000, that there's a drift. And indeed there is a drift, and I can explain why, and it's consistent with my theory. Okay, before I explain why, let me go show you pi. So I'm going to turn off SciPy. Okay, so now we can see that we don't even have the 4-circle placement, and we're using math.pi. And just to confirm that, you can see it's set right here. Pi override value, math.pi. Now, we do have to go back down to this function and change this to a 1 as the viewer suggested. There we go. Now, why is that? Now, I can explain it, and I'm going to. If we go back to SciPy for a moment, okay, we can see the script is iterating pretty fast, and it's holding placements, okay? And if we do increase this position number, what that's saying is we have position 1, 2, 3, 4, okay? Now, let's say I multiply this by 2. Look what happens, okay? What if we multiply it by 3? We get back to 4. 4, we're back to 1. So what's happening is you're actually creating an unnatural step process. Okay, things when they're moving through time or moving through space, they move through positions. They don't just jump positions. They have to move through positions. No matter how fast they're going, they have to move through positions. You have to move through space. So you can't jump to the end and just multiply any number by 100,000 and expect to get an accurate result. That's not how life works. It's not how reality works. And we don't see this in the natural world. Now, this drift that you're seeing here versus with pi, when you do add this back here, the reason you're not seeing that in this particular pi is because we're artificially constraining it, right? And going back to, again, this slide here, I would argue that the reason we don't find this exact value of pi in nature is because it doesn't exist. It's artificially created. It's an ideal for us to explain this Syp gradient. My computer is more than capable of calculating more than 3 decimal places, yet when I draw a circle of radius 1, I get pi equals 3.142. When I set the synergy whole number constant to 1, I get Sypy equals 3.142. That's something that we can actually observe. We don't see this number observably, other than our own irrational calculation of it.